Perl has a very bad reputation, and we love it. Perl 6 is not actually the next version of Perl, it's a different version of Perl. We like to call it the funky little sister of Perl 5. So let's start. First, let's create a function. Sub is the word for function, yani subroutine. And we don't specify any of the arguments. Instead, we just say at underscore. At means an array, underscore means whatever you get. So now we can call it by saying foo42, and we run the code. It prints 42. We can say foo Lamba Labs, and it prints Lamba Labs. This is very nice when you have short programs and you don't really care much about saying what the function does. You really want to write one code at the command line. You just write it and it works. But it's not good if you have a big program because you look at the signature of the function and you have no idea what parameters it takes. So, for example, if we say foo Lamba Labs 42 and foo 42 and Lamba Labs, it's going to still work because it doesn't really care what it takes. So this is good for short programs. It's not good for maintainability. If we want to maintain this program, we should at least say what kind of variables it takes. So now it takes one variable a. If we run the code as is, it's going to say, sorry, check failed, because we gave 2 parameters and it expects 1. This is basically what all programming languages do, like JavaScript, Python, or Ruby. The nice thing is that you don't have to declare the type of the variable. You can just say foo42, and it's going to work. You can also say foo Lamba Labs, which is a string, and it's going to work. So we moved one step above. It's more readable, but it's still practical. You don't have to define many things. However, systems programmers, like C programmers and Java programmers, like types, because types add more robustness to the program. It allows someone reading the program to know what the function expects. In Perl 6, you can use types if you want. You don't have to, but you can. So now we just added int a. If we call the function with Lamba Labs, it's not going to work. By the way, this check is happening at compile time. So my program doesn't compile if it's sending the wrong variable, the wrong kind of type to the function. Now I say foo42, and it works. If I say 42.5, it doesn't work anymore because 42.5 is not an int. Actually, 42.5 is a rational number, so I say rat if I want to use it. That's just a detail. So that's what lots of other programming languages do. We're just combining the robustness of C and Java with the flexibility of Python and Ruby or JavaScript. But we can do one step further. We can invent types as we go and use them in our programs. Let's just do that. I want to create a subset, which is probability. So subset probability of rational, where given P, a probability is always between 0 and 1. So I'm going to add a constraint 0 less than my probability less than 1. So now I've just added a new type to Perl 6, and I can use that type in my programs by saying probability A. So now if I say foo 42.5, it doesn't work anymore because 42.5 is not a probability. If I say foo 0.5, then it works. So you can already see the flexibility this is giving you and the robustness. Instead of having to check in your function every time, is this a correct input, is this a valid input, you just invent a new type, you use it in your code, and it works. It's really practical, for example, in web development, where you can invent a new type for anything the user inputs through the web. And this way you can never have code injection attacks because you cannot, even if you pass this parameter to the functions that deal with the database, they will not work anymore. So this is really nice and helpful. But it also gives us more flexibility. Since we can constrain the parameters that a function takes, it gives us new ways to write, for example, the factorial function. If you guys remember the definition of factorial from school, factorial is defined mathematically as factorial of 0 is 0, and then factorial of n is n times factorial of n minus 1. Now, usually when we want to write recursive functions, we have to put the if condition, the terminating condition, otherwise it's going to recurse forever. But here we can use Perl's implicit type coercion to do this. We're going to say multi because we're going to define different versions of this sub. Factorial, when it takes 0, its value is 0. Multi-sub factorial, when it takes n, its value is n times factorial of n minus 1. And then we just say factorial of 5. And we get 0 because factorial of 0 is not 0, it's 1. No one remembers their math classes. F5. So now it works. Questions at the end? My time's running. We'll discuss it at the end. Okay? So this is one thing you can do with types. As you see, it doesn't run forever because the type system automatically figures out which function it needs to call when it has to. There are other interesting things that you can do with the type system. For example, let's say I have a variable a that contains a number. And then I say a plus 1. And then I say we have a. Now, as you all expect, this is going to print, we have 43, which is a plus 1, and then we have 42. But then I can use the type system to my advantage and say a is 42, but it's also 42. And now whenever Perl 6 needs a number, it uses 42. Whenever it needs a string, it uses the string 42. This might seem like a weird feature to have in a language, but we actually use it every day at work in very useful things that I would be happy to explain to you later. But the thing is, you have so much flexibility that it allows you to do these kind of things. Let's go back a little bit to our factorial function. And first of all, this is not the way I would write factorial because, you know, Perl is really known for looking like line noise, so I'm going to do that. Factorial can also be apply multiplication to all the numbers between 1 and n. So that's another way to write factorial. And then we're going to try if it still works. Say factorial of 5. And it still works. I'm not going to explain this for now, but this is a subject for another talk. It's really interesting, and it allows you tons of things. We're actually here using an operator that operates on another operator and on a list. But that's not what I want to say. I want to say, wouldn't it be really nice if we could just say 5 factorial, just like mathematicians would do? It would be lovely, but unfortunately, that's not a syntax Perl 5 understand. It's an error. You're saying 5 factorial. We could modify the language and then make this work. With Perl 6, we can. We can actually change the way Perl 6 parses the language and changes it. But we probably need lots of time to do this. We only have 1 more minute left. Let's do this. Okay, so to change the syntax, I can say I want to create a sub, which is a postfix. Postfix means like a prefix, but it comes afterwards, which is an exclamation mark, and it does the same thing. And now when I run my code, say 5, bang, it's just factorial. So I can change the syntax of the language as I'm going. Now you might say, but what if someone else wants to work with the code? You just change the language for them. That's lovely. Put it in your own function, sub, foo, and then change the language as much as you want in your own function. It'll work. But then if someone else tries to use this change outside of the function, it will not work anymore. There you go. You can change the language, go inside your own functions, classes, whatever. Make it as specific as you want for your own domain, and then everyone else will not be affected. You're not ruining it for everyone else. Thank you.